Welcome. We are going to try a new activity today. We are going to flip our classroom. I am giving you your notes at home, and then on Thursday, tomorrow, we will go ahead and do our homework in class so I can walk around and help you. It is very important that you make sure you take some notes. Some of this is going to be required, and I'm going to check it as part of a grade. And then, of course, you're also going to have the homework part including. So make sure you write down your notes, and you bring your notes and your book to class. So let's go ahead and get started. Your assignment for now that you need to bring with you to class, you need to answer these two questions. What are we trying to find when we're solving a system of equations? And how many solutions can there be? Okay. Make sure besides answering these questions and maybe copying down some examples so you know what we're doing, that you bring your book to class, because the assignment is out of your book and it's going to be a very long 45 minutes if I didn't bring my book to work on the assignment. So the definition of a system of equations. System of equations is two or more equations together. In Algebra I, we're only going to be looking at linear equations. As you move on to other math classes, you'll be looking at other types as well. We are trying to find where those two lines intersect, where they meet, where they cross. The answer is a point. So I'm trying to find where that point is that they intersect. Okay? So a system of equations is two lines. I'm trying to find the answer that they both have in common. Where do those two lines intersect? The different number of possible solutions. You can have two lines that intersect at exactly one spot. So this is going to have one solution, 1 point. I need to make sure I write my answer in coordinate point form. You could have two parallel lines. This would have no solutions. And if I draw two parallel lines from my problem, I would just write down on my paper, no solutions to that. And then you can also have a situation where you have the exact same line, they're just in two different forms. So then my answer is all the points that are on this line, because those points work in both of those lines. So I could either have one answer, I could have no answers, or I could have all the answers on my graph. Let's go ahead and go through some examples. Before we can do that, real quick as a review of graphing, you may need to pause this video so that you can write this down if you don't remember how to graph. If it's in slope-intercept form, I can start with the y-intercept on the y-axis, and then I use my slope, rise over run, to go to the next point. If it's in standard form, the easiest way to do this is to use your 2 points, your intercepts. So I plug 0 in for y, and I solve that to give me x. I plug 0 in for x, and I solve this to give me y. And then I would graph those 2 points. Again, your x-intercept and your y-intercept would be where you would graph those values, and then you would draw your line. Your other option, which some of you like to do, is change it into slope-intercept form, so solve for y, and then you can go through that as well. Your graphs need to be accurate. We need all those points on them. If they're not, it's very difficult to find that answer. So it's extremely important you know how to graph lines. So our steps to solve, we're going to start off and we're going to graph both lines on the coordinate plane, the same exact plane. What are we trying to find? That point what they both have in common. So I'm going to take my graph and I'm going to find out what is this point. If I have two lines on my graph, I'm trying to find what is this point. And I'm going to write that point down. And then I'm also going to walk you through how to check it so that you can make sure you know if that works. So here's our first example, graphing with the system of equations. The first one's in slope-intercept form. So I'm going to start with my y-intercept at 1. So I count up 1 on the y-axis. I'm going to use my slope of -1/2. So I'm going to go down 1 and right because it's +2. I would keep doing this so that you have all the points for that line. So up 1 and over 2 is also the other direction that I can go. Now I know exactly where all those points are. I would grab my ruler and I would draw my line. For the second one, this is in standard form. So when it's in standard form, I'm going to find my x-intercept. So x equals 18, because this is going to be 0. So that's 18, 0. And I'm going to get to what I would do on my graph here in a second. My y-intercept, I'm going to put 0 in for x. So 6y equals 18, so y is 3. I can't graph this one, but I can graph 0, 3. So the other piece of information I need is my slope. So if I don't have my slope, but I have 2 points, I can find my slope, we learned this last semester, by subtracting the y's, subtracting the x's. So 3 over negative 18 is negative 1 over 6. So now I can go down 1 and over 6. 1, 2, 3, 4, 5, 6. Okay? You can also go up 1 and over 1, 2, 3, 4, 5, 6. This right here, I'm going to make it darker, is where both lines intersect. I still want you to complete your line because the graph is part of your answers. Then I'm going to write down what this point is. So I have to count 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. So that's the point negative 6, 4. That is my answer. If you want to check that, plug negative 6 in for x. So negative 1/2 times negative 6 is 3, plus 1 is 4. If this doesn't work, you know you've done the problem wrong. If you're plugging it into standard form, plug both x and y in. So I would have negative 6 plus 4 times 6 is 24. So negative 6 and 24 does add up to 18. If this point does not work in both your lines, you've made a mistake. Okay? If you still need more time, I'd pause the video. We're going to move on to the next example. Okay? So I have 2 equations here. One is in slope-intercept form. I'm going to start with negative 7. I'm going to go down 5 and over 3. Now, 1, 2, if you needed to, you could do this, but remember, negative 5 over 3 is 5 over negative 3. So I can also go up 1, 2, 3, 4, 5, and left 3, so that I have my line. This one is in standard form, so I'm going to plug in 0 for y. 5x equals 0. X is 0, so that's the point 0, 0. Now we run into a little bit of problems here, because when I go to find the y-intercept, I also get 0, 0. Well, I can't find the slope between those two because they're the same point. So I'm going to have to put this one in slope-intercept form. So I'm going to subtract the 5x. I'm going to divide by 3, and now you'll see the y-intercept is 0, and I'm going to go down 5 and over 3. Now, some things that we have learned from other previous chapters. You'll notice these 2 lines have the same slope. If they have the same slope, we already know that they are parallel. They're not the same line, they're 2 different lines, so this has no solution. You need to write that on your paper, or I'm going to assume you don't know what that answer is. So I have my parallel lines, which represent no solution.